Thank you for joining this lesson. Let me start from part B, uniform circular motion. We are taught to state two factors that affect centripetal force of a body moving in a circular path. Therefore, the factors that affect the centripetal force of a body in a circular path are mass of the body, m. We also have radius of the path, small letter r, and we also have linear velocity. Of the body v. Therefore, linear velocity v is also another factor that affects the centripetal force of a body in a circular path. With this now, I can briefly relate the three factors to the centripetal force. So centripetal force is usually directly proportional to the mass and the square of the velocity, but inversely proportional to radius of the path. This means, doing away with the symbol of proportionality, we can say that force centripetal equals to mv squared out of r. mv squared out of r. Part C, a stone of mass 1.2 kilogram is tied to a rope and whirled in a vertical circle. The language here is vertical circle of radius 3.5 meters with a speed of 6.32 meters per second. Calculate part 1, the centripetal acceleration of the stone. The language here is centripetal acceleration. Remember, centripetal force is mass v squared out of r. And it should be noted that from Newton's second law, which says that any accelerating force is given by mass times the acceleration, then in the centripetal case, centripetal force is given by mass times centripetal acceleration. And now, according to this formula, the coefficients of A are v squared out of r. Therefore, we can say, since the two equations have to agree, then A is represented by v squared out of r in this equation here. Therefore, centripetal acceleration is equal to v squared out of r. v squared out of r. So for this case, acceleration centripetal is going to be v squared out of r, a v of 6.32 squared divided by radius of the path 3.2. This is going to give us, when we take 6.32 squared, then we divide by 3.2. This gives us 12.48 meters per second squared, since it is acceleration. So that is the centripetal acceleration. Part 2, the tension in the rope when the stone is at the highest point. So in a vertical circle, there is a moment when along this path, the stone will be at the highest point. Remember, at the highest point, the centripetal force will be given by what we call tension on the string, which is acting towards the center, and also weight of the stone, which is also acting towards the center and downwards. So because tension and weight of the stone are both acting downwards, then centripetal force is going to be the summation of the two at the highest point. So at the highest point, we can remain with the tension now. We make tension the subject, such that tension is equal to centripetal force minus the weight of this object. It should be noted that at the highest point, tension is the least, because it is being given by the difference between centripetal force and weight of the object. So this tensional force at the highest point is given by centripetal force mv squared out of r minus the weight of the stone, which is mg. So this is going to give us, when we take mv squared out of r, we're going to use the mass here of the stone. We are told that a stone of mass 1.2. So 1.2 multiplied by v squared root of r, which has already been calculated here as 12.482, then minus mass of 1.2 times g as 10. Therefore, when we multiply by 1.2, this value we're going to get a 14.98, then minus, this is going to be 12. So when we take 12 and subtract from this figure, we're getting 2.98 to 2 decimal places newtons. So this is going to be the tension at the highest point in the vertical circle. Thank you for following. Subscribe and share.